Hey guys, welcome to Code Decode. Today in this video, we will be looking about all the kinds of databases out there available in the market for you. There will be relational databases available like MySQL, Oracle. There will be NoSQL related databases like key value store, document databases, graph databases and columnar databases. We will be looking into each of them a bit so that when a system design interview question comes, you should be able to decide which database will give you better performance in which scenario, and you will be able to answer such questions from interviewer like why did you use document database and why not key value database? Wouldn't key value have given you a better performance? So such kinds of trickier questions will for sure be asked. Even in a simple interview also, if you say in your project you have used Cosmos DB or MongoDB, they would have asked you why not graph DB, why not column DB, why not relational databases you have used, why NoSQL you have used. So to answer such questions, you should know that there are mainly major kind of 5 databases out there, which is to be used, when it is used and why it is not used has to be very clear to you. So let's get started and see all such type of databases out there in market. Please like, share and subscribe to support us so that we can keep giving such contents to you and this content reaches to more of the people who are preparing for interviews like you. You have some NoSQL databases, you have some relational databases. Even in a high level design, they will ask you which database you will choose. So you will always have a big option between NoSQL and relational databases. So when to choose what has to be decided by you and on some very strong grounds. So first see that the application that you are trying to design or create is read intensive or write intensive. Read intensive means you will read a lot and update less, and write intensive means you will update a lot. You will keep on updating your data. So if it is just a reading that you need to do and less of write, then go for NoSQL databases. But when it is write intensive, go for relational databases. Now why do I say that? If you have to read a lot and update less. Now suppose I'll give you an example. You are running a student university. The first time student enrolls, he enrolls all his personal information in your databases like his student ID, student name, his permanent address, his temporary address, his postal addresses, all the type of addresses he has in your database. Now if you create 2 different tables, say a student table, address table, and create multiple foreign keys and such joins, then whenever you have to read about a student, you will always have to put multiple queries, complex queries and read about your student. But you know that only once you have to update in your database, and rest for all those upcoming years, you will mostly have to read about your student. You will only have to query about your student and not update the student data much. In that case, it is better to go with NoSQL databases as it will prevent you from creating views, complex queries, joins. This will all be reduced and hence your performance will increase, speed will increase, readability will increase, and hence all the non-functional parameter will be good for your application. Where if you have used relational ones, then you have to put all those queries to get a simple single data for a single student. So that is why it is said if it is read intensive, you update very less, go for NoSQL, else go for relational databases. Not just this criteria, also see that your data is structured or not. So relational database requires you to have a structured data. So suppose this is your student table. So here this is a proper structure you have to follow: ID, name, age. Anything extra, you next need to add another column, and that will be a hectic process. And every time you know that only these fields are going to come, then go for relational ones. But if from the field you get sometimes the only name and ID, sometimes you get name, ID, address, and sometimes you get name, ID, address and mobile number also, then it is not a structured data. Sometimes you get something, sometimes you get another fields. Then in that case, when it is not structured or it is unstructured, go for NoSQL databases. Apart from that, the best part that relational databases gives you is concurrency and atomicity. So asset properties are something which is always followed by relational databases and which is always missing from the NoSQL databases. So if you need concurrent application, that means concurrency is your top priority. For example, in applications, right, like Book My Show or hotel booking, in such concurrent applications, several users will be trying to book the hotel room or will try to book the movie ticket simultaneously. Now in such applications, Asset properties is a must. Consistency is must. Because if your data is inconsistent, you will end up booking a same room double or twice to two different people, or you might end up booking the same movie ticket to two people. So a coordination, consistency is very much required with several users simultaneously accessing. Then go for the transactional or relational databases, as asset properties will be followed really good there. Also, there is a cost associated with the relational databases. So relational databases are usually not open sources, and you have to purchase usually the licenses for it. So if you have the less budget allotted to your project, go for NoSQL databases, because they are usually mostly open sources. They are freely available, and hence if the less budget is allotted, go for NoSQL one. If you have enough budget, go for the licensed one. Lastly, a very important part, tolerance for redundancy. So here if you can see, this is my relational database, where this is a table for student. There will be one more table for address having the type, pin and city. When you create a NoSQL document for this, you can see that this address, type home 12345 Bangalore, type home 12345 Bangalore, is getting repeated again and again. So this is why there is a too much of redundancy in every document. Even if the address is same, you cannot directly point here, you cannot do that. So this is why there is too much of redundancy in NoSQL database. But the best part is, when you want anything about code, you will get it at one place. You don't have to do any kind of join. But there is disadvantage also, that there is too much of redundancy in NoSQL, which is eliminated in the relational databases. So if redundancy tolerance is not there at all, go for relational databases. Keep on using foreign keys, views, joins and everything. If redundancy is tolerated enough, go for NoSQL database. So that was pretty much about all the scenarios, when to use relational one and when not to use the relational one. Read and write intensive, unstructured, structured data, asset properties, cost and redundancy. These five majorly will decide when to use SQL, when not to use relational. I'll give you one example. If the interviewer asks you, you have a book my show kind of application, then you should always go with the relational databases, because you need asset properties to be followed. If it says it is an application where you have a product to be stored, this is an e-commerce application, the product has to be stored and all the attributes are there. Sometimes you get some attributes of a product, sometimes some attributes are missing for a product. Then since it is not a structured data, something are missing, some columns are missing, sometimes it is more columns than expected, then go for NoSQL, because it is unstructured data. So such kind of decisions you have to take based on scenarios, but the underlying decision will always remain in these scenarios: read, write, unstructured, structured, asset properties, cost and redundancy. Next, we have four types of major NoSQL database out there in market. You have to choose when to use which type of database based on your application. Similarly, how we have decided between the criteria between SQL and NoSQL, similarly I will show the difference between these four also, so that you can easily decide between which database to use when. So remember, these are types of databases, and the databases like Cassandra, MongoDB becomes the type of such subtypes. So these are subtypes. So for example, Cassandra is a part of column database, MongoDB is a part of document DB, Redis is a part of key value data store, Neo4j is a part of graph DB. So all the NoSQL databases out there will be in these four subcategories only. So if you understand these sub four categories, you will be good to go with any kind of databases out there in the market. So let's get started with the key value store. First, I will give you an example. So if you can see, this is a key, this is a value. ID is the key, 123 is a value. Address is a simple key, but value is a complex object of multiple key value pairs. Key value store is a type of NoSQL databases which is known for its simplicity and the fastest performance. And remember, this is the simplest of all the databases, NoSQL databases out there in market. Now you have learnt about hash maps, right? Hash maps internally uses hash table. So this key value pair in a hash map internally will be stored as key and a value. Key is ID, value is 1. Key is name, value is code. Key is address, value is this much long data. Key is a unique one and value can be anything. It can be a simple string, simple integer, or even a complex object, right? Like an address object here. And similarly, like in hash map, what we do, we fetch everything using key. We put to the key, we delete using key. So key is unique and key is very important. So here in this key value store also, everything is based on key and the value is associated with each unique key. Now if in real time example you want to know something, you can consider a dictionary. You search a word and you get the meaning as its value, or a phone book directory. You search for a name, the value is the phone number. A simple string or a simple integer or even a complex object can be stored as a value. That's a key value store. When to use it? Now remember one thing, whenever you get using a key, you get the whole value and you cannot filter based on value. I need only those addresses whose city is Bangalore. I cannot do that because you can always search based on the key, that is ID. You cannot search, or the address, you cannot search based on any of the values. So value based filtering is not possible in key value store, which can be done in the document database, which is coming next after this. So when your application needs to handle lots of small continuous reads and writes, which is very fast based on one unique key, and all the operations like update, delete, fetch can be done using that unique key in a constant time with the best performance, you can use the key value store. Now you will ask me, what is an example where I can use it and where I cannot use it? So I give you an example of a session. So whenever you create a session, when a user logs into a web application, there you have the whole user information. So consider this user ID and the user session object. So here what you store is 1 user session object 1, 2 user session object 2. This is how you store a key value pair, and when you want to get the session, you can get using the user ID. And when you want to end the session and delete the whole record, then just using this user ID 1, you can delete the whole record. You don't have to fetch anything explicitly from the value. So value comes as a whole. Even if you want to update anything, this is a disadvantage of key value store. If you want to update anything in the value, you will get the whole value. You cannot filter it out. You will get the whole value, take it, modify anything and put the whole value again. You cannot do partial update in the value. So that's how you can use to maintain the session data using the key value pair. Secondly, a shopping cart. Since in the shopping cart we need a loads and loads of quick processing of cart, the e-commerce website receives billions of dollars in seconds during a very holiday shopping season. To handle such large scale of data and extremely high volume of changing millions of services of users, you can store the users and its cart information in key value pair and remove and delete the user as soon as they come and go. Also cache. Now you can store the cached data, which is obviously temporary, in the key value store. Now you know that as soon as the time to live is done or the expiry comes for that particular object, you have to remove the whole object from the cache. So no partial operation has to be done on the object. Either you will read from the cache or you will remove from the cache completely. You will not do any filtering on the value. You can store employee even ID and the whole employee object as a value in the key value store. Now some examples of such databases is Amazon DynamoDB and Redis available in market, which is key value store. Where you can use it in cache applications, in the applications where you need to store the session data. But where you cannot use it is, say suppose e-commerce, where you need to store the product information. Now product information will be in the form of key value pair. So what happens is your key will be 1 and your value will be this object. Then your key will be 2, your value will be this object. This is key and a value. And then the key will be 3, value will be this whole object. But if you want to partially update any of the size, you cannot do that with a key value store. So if you want such data to be stored which is partially updatable in the value, you do not store such information in key value store. You can rather use document database to store such information rather than using the key value store. Now advantages, disadvantages, it is very simple, straightforward. Give the key, get the value. Give the key and value, store it in the table. Give the key, delete the value. Simple, very simple. Key value straightforward, hash table being used at the backend. Speed, order of 1 is a constant time of retrieval updation. Why? Because it is the hash based. So it is constant time read and write operations. So this is the fastest of all NoSQL database available in the out there in the market. Problem is you cannot perform filtering on value. I told you, you will get the whole value. You cannot filter on the basis of value. The only you can do is filtering on the basis of key. That is the only thing you have. So it is not suitable for complex data, and value has to be updated as a whole, which requires to get the complete value, perform the required processing, and finally store the whole value back to that key. So this is a performance issue because it takes a lot of time to first read it, change it, then put it again. So this is too much of processing. So rather than doing this, you can also update the value partially using the document database. Now when you can use the document database, and what is document database? If you have data in any of the open formats like XML, JSON, BSON, then you can create the documents in the databases. For example, what I have shown you here is in the form of JSON, key, a value. So this is key value pair, but this is a JSON also. This is an open format. Here that you have seen is a key value pair. Key can be anything. It is not necessarily a JSON. This format is not a JSON format. So if it is an open format, then you can use a document database. So the best part of document database, it can also include some structural and hierarchical data also. And such kinds of database are widely available. And example of such kind of database is MongoDB. So MongoDB is a document database which usually have the formats of XML, JSON or BSON. So even unstructured data can be stored, even structured hierarchical data can be stored. So this is open to both kind of database. Now the best place where you can use it is you have a products, and products have the hundreds and thousands of properties. Sometimes some properties are visible, like for example size, this is for clothing. Now color, this product like paints, there can be some more which who doesn't have even colors and size as an attribute. With multiple different attributes coming for the different product, you can always use document database to store them. There is no restriction on number of attributes. You can use any number of attributes in a document. So when you have some application where individual attributes may change, then go for document databases. And you have an open format also possible, that is you can store it in XML or you can store it in JSON, BSON, then go for document databases. Advantages: fast querying, filtering on the basis of value is also available. Large data can be easily handled and stored in a hierarchical format also. But the disadvantages, the querying is limited to keys and indexes. Still the querying can be done based on the keys only and indexes only. So this is a problem still with the document databases. But apart from that, key and value store, and this is almost same. Apart from the possibility of filtering values partially in the document database. So if you have e-commerce website, you have multiple products, catalogs to be stored, go for document database. Now next is a very interesting database, that is a graph database. Now graph database internally uses graph data structures, and if you know what is a graph data structures, it is composed of nodes and edges. So suppose this is a graph, it contains nodes and edges. So edges shows the relationships and node shows the entity. So here my entity can be a person. So entity is my person. Now person has a name code, John and Alice, and the edges, that is the link between them, shows what is the relationship between them. Now I'll give you an example of Facebook. Now on Facebook or Instagram, you have people connected with you, right? Now few people are your close friends, few are your friends, and sometimes when you are married to, you show it as a link that you are married to this person. Say this is how you denote it in a graph database. Your entities becomes the nodes, your relationship with another people becomes your edges or relationships. So code is a close friend to John, but John considers code as just a friend, while John is married to Alice and Alice is also married to John. So this is how you show a relationship with node and edges. So this is the way you can arrange the nodes according to the relationships and store it in database. Some well-known graph databases are Infinite Graph, Neo4j DB and many more. But when is the best case to use graph databases? The best is to use with the socializing apps where multiple people are related in a different ways to multiple other people. So social networking sites, then recommendation engines. So recommendation engine creates the nodes like this. So this is a node person, this is a node entity as food, and another entity also as food. This person code likes burgers but doesn't like South Indian food. So this is how the next time you try to surf again, it will give you more recommendation for burgers, types of burgers, and will not try to give you any notifications for South Indian dishes because you don't like it. So this is how recommendation engines also store the relationships on your behavior, what you have liked and what you have not liked. Similarly, logistics, like for example, if Flipkart, Amazon, you try to see something, you will see the related searches. So it will see that you have liked some kind of product in the Amazon. Next time it will try to give you recommendations on the similar type of products that you like, so that you purchase more. So behavior of you is stored with the graph database as a key, as a node, and the relationships in the graph database. Suppose I give you an example that please design a system for me for Facebook or Twitter or Instagram or these such kind of applications where there is a relationship between two nodes or entities, then always go for the graph database. This is the best way to give a view on how different entities are connected and what is their different relationships with each other. The last one is the column database. This is something which you will use the least because this is used in the analytical applications. Now you have seen the relational databases. The relational databases are meant to be read from left to right, row wise. From left to right, each row is read. So if you have 100 rows and 100 columns, and if I ask you to find an average age, what you will do? You will go left to right, keep on reading, so you will parse 100 into 100, that is 10,000 fields you will read, right? So this is the disadvantage of row or the relational databases, which is row oriented. Hence came the column databases, which is something in between the NoSQL database and your relational databases, where the data is stored in the column wise. Also in the column family wise also, sometimes when you have two things to be combined, you can keep two columns also in one single file. What is the advantage? Now since you just wanted age, average age, rather than going through all the ID, name, all the rows, you just go to the column. Column databases are designed to read effectively and returns with a greater speed. So this is only for performance. When you have to find something based on only one single column rather than hundreds of columns, go for the column database. Now when to use column databases? In the business intelligence, in the data warehousing, in the reporting system, in applications like where you need to calculate some average of some column like salary or age. Go for faster retrieval of column because column database is meant for that, so that no traversing of rows on the disk, and you can quickly calculate the average of that particular column. However, sometimes column database is not ideal when you have to view multiple fields in each row. Now suppose I say I need all ID, name and age. Now you go on column wise, and now you match age 30 is for ID 1, for John, for this index, for this index. So though all these will be stored in the same indexes. So the ID 1 will be stored with index 1, John will be stored with index 1, age will be stored with index 1. But still you have to map, right? Index 1, John and 30 has to be mapped together. So better than if you find multiple fields in the same row to be fetched, go with the relational databases. But if you have only one or two fields or column to work upon, go for the column databases. Also, column takes more time to write new data because now you have to not only write to the column but also have to make sure this index is proper, so that when you want to merge multiple columns, the same index column can be merged. So even write is very slow in case of column databases. So if it is more write intensive, go for the relational databases. This is also something we have seen in the first slide also. If it is read intensive, go for NoSQL. If it is write intensive, go for relational databases. So that was all about multiple databases we have out there. I also have partitioning, replication of data in databases, shredding of data. I have to cover all such things in databases. I can directly go into design a Facebook or design an Instagram, but if you don't understand why we use which database, why did we use shredding, why did we use this particular partitioning, you will not be able to answer the tricky ones, like why did not you use the column database, why did you use a graph database. So such questions has to be answered. You need to go a bit deep into it. So if you want more such questions like what is partitioning, what is shredding in database, just let me know in the comment section. I'll create another video on that. Thank you.